All right, so I'm gonna get started now. My name is Austin Bowling, and I am hosting this webinar on behalf of Ideas, which is a nonprofit organization aimed to bridging the gap between academia and industry with respect to data science and AI and blockchain and related topics like that. So we built a data engineering and science hub by providing connections and resources for business leaders, professionals, and also promising students and people looking to get into the industry. And one thing that's important to be mentioning is that we're going to have a big conference on the 20th of October at the Los Angeles Convention Center. And if you're in the LA area at the time, then you should definitely check that out. And for more information, you can go to our website at ideassn.org. And I'll put that in the chat as well, so you can just copy and paste that. And so for today, we have our host, our panelist, Neal Fultz, who he's going to be talking about a data science topic. And I'll leave the self-introduction to him. And yeah, we'll just go from there. Thank you.
All right. Thanks, Austin, for introducing me. And thank you all for joining on a Saturday afternoon. I know there's lots of fun stuff out there that you could be doing, but you're indoors and listening to me. So I will also be speaking at the Ideas Conference in a couple weeks in LA. If you're in the LA area, I'd love to meet you all and chat about data science in person. Today, I'm just going to be kind of talking through the project that inspired our talk that'll be coming up, and we can kind of, I'll talk for 15, 20, 30 minutes, however long, and if I start rambling, stop me about that, and then we can switch over to Q&A. So I'll kind of start at the beginning, I guess. So one of the things I've learned in my career is it's very good to kind of know what's going on out there. So I just over the years signed up for probably 50 or 100 different mailing lists related to data science. One of them is by an organization called DataKind, and they are a nonprofit that exists to connect data science volunteers with nonprofits that have data and don't necessarily know what to do with it. There's a couple of these out there. So there's DataKind, there's Statisticians Without Borders, and I think there's a couple other ones. So it's just kind of good to, have those things on your radar because you never know what's going to pop up. And so about 6-7 months ago, I did get an email from them and said, hey, we're looking for volunteers to work on this new project that's going to be working with higher ed data. It had a link to a Google form. So I filled it out, didn't hear anything, over the holidays, kind of as you would expect. And then after the new year started, they got back to me and they were putting a team together, and it had a lot more details about the project. And it turned out that they had partnered with multiple other nonprofits in the state of Wisconsin to look at what are the kind of causes of student success in universities there, which was, kind of interesting. It's a lot different from my day job working on online advertising data, that kind of thing. So I ended up joining onto that project and getting into the details. And the details were kind of overwhelming at first. It turned out we were working with the University of Wisconsin at Parkside and Gateway Technical College, which is a 2-year technical college in the same area. And they were working with 2 nonprofits, one called Higher Expectations of Racine County, and then Strive Together, which is a nationally focused nonprofit with kind of the goal of ensuring that people reach their full potential. University of Wisconsin Parkside is a 4-year public university with about 30 majors, a couple thousand students, and again, Gateway Technical College offered associate degrees, some certificates. If you wanted to become a nurse or something like that, that'd be a good place to go. And this is all kind of in the southeastern Wisconsin area, kind of north of Chicago is kind of my understanding of it. I've never been there, but all the people I've talked to over there seem pretty nice and decent folks. So I'd like to just, give a shout out to them. The idea there they had kind of come up with was to take all this student data that they had sitting around in their assorted databases, and see could they actually use that to predict student success and to identify what variables were leading to successful outcomes or unsuccessful outcomes. So that was the general idea, and I think that a lot of universities or a lot of institutions are kind of looking at this. So that's kind of where we started. It turned out that with the Gateway College, we were able to get about 11 tables worth of data, which covered 24,000 students over 5 academic years, and it contained your standard demographic data, so gender, race, age, stuff like that. There were also some extra demographics that would be a little bit non-standard, at least in ad tech. So you're able to get if they were a first-generation student, if they were a displaced homemaker or a single parent, things like that that are a little less common in online advertising or marketing. We also got a lot of data on transfer students. There's a lot of students that start at a technical college and then they transfer to a 4-year. And there's a lot of students that are at a 4-year and they transfer to the community college to work over the summer. And we had quite a bit of data about that. We also were able to get some achievement data, which included which courses they were taking, what grades were they getting, and did they eventually finish their program. And finally, we were able to get data on financial aid packages. So had they applied for financial aid at all? Were they awarded loans or grants or scholarships, stuff like that. And on the Parkside UWP side of things, we got very similar data, but since they're not open admission, you do actually have to apply. We got even more data on that application side. So what was your high school GPA? Did you take the SAT? What were the scores? Things like that. And so from there, we wanted to get to this place where we could actually make some concrete recommendations to the schools. I was put on a team with several other data scientists, and we kind of got started on that. The first step was kind of just to really meditate on what does success even mean, right? Because a lot of people might be successful, but they might not fit the federal definition of student success, which is actually a thing that's out there. And the federal definition is roughly if you finish within the expected time plus 1 year. So if you're at a technical college, which expects completion in 2 years, did you finish in 3 years or less? And similarly, in a 4-year institution, it's whether did you finish in 5 years or less. So this had kind of a interesting implication for transfer students, because if you're, like I said, a small community college, for example, a lot of your students might transfer out after 2 years and they might not actually take the one course they need to get their associate's degree. That's pretty common. And if you look up these two schools, on the federal scorecard, it shows they have graduation rates around 30%. And again, that's because even if you're successful, by your own definition, you might not pick up that associate's degree. You might leave first and transfer up to a 4-year. So there's probably a good couple weeks of debate just around what problem are we actually trying to solve. And what we ended up doing was, did you not drop out? Right. So this is kind of like solving the opposite problem to kind of be able to get yourself forward. And that's kind of a trick I've used many times over the years. So yeah, that's what we ended up deciding was success was not dropping out. And from that, we had kind of a clear target variable that we were able to progress with. So then we moved on to kind of what I would call like experimental or prototypey phase, where we tried out lots of different machine learning algorithms in order to see if we could actually predict whether people would complete or deactivate or not. And, we tried, good old random forests, which is one of my favorites, and different gradient boosting methods. And so that they fit the data pretty well. But ultimately, when we ended up talking with our sponsors, the hosting nonprofits, these things are black boxes in a lot of ways, and they wanted something more interpretable. And so the gold standard for interpretability, like what everyone in industry uses, is you go back to logistic regression. And when you do that, like at least initially, it just doesn't fit the data as well. So then we began kind of a more manual process of backporting the interactions and the nonlinear features that are more complicated methods had detected, and backported them into that logistic regression as just features. So a good example of that would be using the age variable. It turns out that 21 is an important age if you're going to college, and there's a nonlinear effect on whether you finish or not based on your age when you start college. If you're older than 21, it tends to have a positive effect at one school, but not at the other. So there's actually an interaction between those two variables in addition to the nonlinearity. But once you have some kind of method to kind of pick that out, you can take that out of your random forest and then plug it into logistic regression, and then it's fitting the data just about as good as the actual random forest. Another kind of wrinkle that we encountered is that these are kind of multi-year problems, right? And so what you don't want to do is just take all the students and then score them exactly once, because most people don't drop out like right away. It's usually there's a certain rate or certain slice of the student population that drops out in their freshman year, and then a different kind of segment that drops out in their sophomore year and junior year and so on. And kind of taking into account that time component ended up being pretty important. And so our initial thought was, well, maybe we just need a model for every year, or maybe we should use some kind of survival model that can kind of incorporate that more naturally. What we ended up doing was for each year that a student was in there, we kind of expanded our data matrix, so the unit of observation was the student year instead of just the student, and went with that. And then we were able to get pretty well calibrated predictions. What else did I have to say specifically? The other interesting thing that was very surprising was actually working with the course data. And so for every single course that these two schools offered, for every single student, we knew if they got credit for it or not. And so you would think, obviously, this is pretty important in terms of whether people actually complete or not, because if you fail a class, that's been, kind of a waste of time and money, right? You didn't get the credit for doing all this work and time that you put in. So that doesn't fit cleanly with this idea of having the student year as the unit of observation, right? Because, in a typical year, a student might take six or eight classes typically. So it ended up blowing out our, either our feature space or our row space if you started looking at the course level. And so we did kind of a normal thing and pivoted the data. We took the 50 most popular courses by enrollment for each university and coded those out, whether the student took the class or not, whether they got credit for it or whether they failed. And since this is logistic regression, you get kind of a coefficient or an effect of passing or failing each of those. And then you can look at the difference between the passing coefficient and the failing coefficient to get a sense of like, how much does this help you get towards a 100% predicted completion? So that was another thing that I'll be talking about in more detail in my talk in 3 weeks. Anything else to really mention about the modeling side of things? Oh yeah, so just a slight digression just on the different tools we were using. We actually started out using Python and Jupyter notebooks, and then we switched to R halfway through. So this is not something I would generally advocate, but it turned out like everyone on the team was much happier using ggplot2 for the plots. And since that was a pretty significant component of our communicating with the nonprofits, made more sense to, like, since we were just using a logistic model anyway, to just retrain in R, and then we could do the plots easily than it was to use Python and get the easy training there, and then having a harder time with the plots. So that's one of those kind of funny things to meditate on. Yeah, I think that's kind of the notes I had put together for today. So I can, I'll just take a second to see if there's any questions for me, or, and either about this project or anything really. Okay, so I got a question from Solomon Davida. Thank you. The question is, were there any non-demographic data, distance from school, etc., or student impressions logging into learning management system that were considered? So yeah, so in terms of distance to school, that was actually an important variable. It was not, and that kind of entered into the model in a couple ways. So the first way was we knew where they went to high school. So we had that zip code and could say, all right, the students that are coming from within this county are one group of students, and then students that are moving here are another set of students. And then secondarily, we also had access to whether they were living on campus in a residence hall, and which one specifically, or were they living off campus while they were going there, and were they full-time or part-time? So that ended up being pretty influential. It turns out that, a lot of students, if they were coming from out of state, completed at higher rates. And I mean, that kind of intuitively made sense to us, because if you're paying out of state fees, you're probably a bit more committed than if you were, just kind of were already there and had a lower buy-in. And then the other part of your question was about student impressions, like if we could see when they logged into Blackboard, for example. We didn't have any access to that data. And I'm unclear to me if the school administration would have good access to that data or not, just based on that. I would assume that data would live with Blackboard, and maybe not with the school specifically, but I don't know. But yeah, that wasn't something that we had access to, but it probably would be interesting, definitely. Thank you. Were there any legal non-disclosure agreements required or FERPA considerations with the data management? Yeah, definitely. So everyone on the team had to sign an NDA and agree to not share the data, the raw data with anyone. we had all our data living on a reasonably locked down server that we could all log into, and we did all our work there. So the data never made it onto the internet, let me put it that way. And then for FERPA considerations with the data management, this is one of the things where it was nice being able to work with several nonprofits. Is I'm a data scientist. I mostly know about those things. I'm not an attorney, and I don't know all the regulations involved with this, but it seemed like if we had our EC2 instance, it was locked down, needed a private key in order to log in, then that was good enough for everyone involved. Yep. Let's see. Oh, so it turns out that in Zoom, there's actually questions can go into chat or they can go into Q&A. So I have another question here. Can you explain again about how shifting to Python and Jupyter notebooks changed things for you and what else you were using? Yeah, so like I said, we started out using Python for all our data analysis. And that worked okay. The notebooks, this is my first time really trying to use notebooks in a hosted setting where it was on an EC2 instance, and I had to kind of go through that for managing packages and everything like that versus having it on a machine that you own yourself and can kind of fix that way. When we that also was kind of us learning how to, use sklearn, fit the different trees or different logit models to the data, and prepare some nice looking plots. And like I'd used R and ggplot for many years. I was pretty comfortable with it, and like it's just a killer app. It's very hard to go to another plotting package after you've kind of used ggplot for quite a while. It is really quite good. So the other comment I would make is that since we were on EC2, we could still use RStudio. They have a server version, so that works pretty good. The only thing to watch out for is kind of if you're running the server version, you're in a browser, and sometimes the browser steals your shortcut keys. So if you use Control-R for the history search or whatever, it reloads the page, which is super annoying. So yeah, what else did in terms of other things that we used? We also used SQLite or SQLite for the database. So, I mentioned we had like 11 tables that we had to stitch together. Typically, we did that by, just writing SQL queries and then just executing those against that database and then loading it straight into a data frame. Both pandas and R make it pretty easy to just like have a SQL query, run it against a database, get a data frame back. So that's pretty nice. Okay. Okay, another question in chat. How did you get your start in data science? So I think I'd always had kind of an interest in probability. I remember when I was a kid, you'd my dad would take me to the horse track, let me pick a horse or whatever. And then as kind of like an exercise, we'd have to figure out how much money we might win or lose or whatever. So definitely from that, or playing cards or whatever when I was in college, that was kind of an interest. But I was a computer science major, and definitely more into the software development side of things. I really got interested professionally, I think, with my first job out of college. I was at a enterprise software company up in the Bay Area that developed predictive analytics for consumer packaged goods. So we would work with like Coca-Cola or I don't know, Wendy's or whatever, and try and predict how much units they would move, right? So if they sent out a coupon, how many more units would you move? So I was kind of the second generation engineer on that project. I was hired kind of after the initial wave of engineers when it was still a startup. They had started to leave, and they hired me on. So I was mostly focused at that point, kind of maintaining that code base, making sure that it didn't crash whenever our, high dollar clients would log into our system and, try things out. And I started learning, kind of the predictive modeling that way from having to take care of this system. So it was a really interesting experience. And then when the recession happened, that company went out of business, or I guess we got bought or whatever. So then I went back to school to do statistics, and that was kind of a mercenary decision. I could have gone back to computer science, but my general sense was that as a statistics PhD student, you would get, typically you would be a TA, versus in computer science, you'd be working in a lab. And at that point I needed some time away from coding. So that's kind of how I ended up in statistics, in an academic sense. And then after that, I was in LA, ended up working back in the startups around here. And that's what I've been doing ever since. Let's see, another question. Do you have any advice for people starting out based on this? Yeah, so one specific piece of advice is to, try and be connected with the community and be involved, like sign up for the mailing lists. It's better to like get 100 emails a day and delete them all, because, sooner or later you're going to get the one email that comes through that maybe changes your life. You get a new job, or you find out something new, or you get a cool project out of it. I tend to think of it as just playing the odds, right? Like, playing the odds is kind of like a core concept in data science or in, decision theory or whatever. And I would say we should apply that to email also. So it's always good to, sign up for the mailing lists, reach out to people, because you never know. If someone pings you on LinkedIn, take that connection. You never know. You might bump into them sometime. I think 3 people have already added me on LinkedIn just ahead of this conference. And, when I'm there, hopefully we get to chat. They seem like good people. So yeah, that would be my advice. On the more technical side of things, I would really recommend, in addition to learning kind of the data science tools, also learn some of kind of the more platform related stuff. So if you have like a basic knowledge of like Amazon Web Services or Docker or things like that, it can make your life a lot easier. You're going to be able to work on a team with platform people and understand what they're talking about. For example, you don't need a degree in computer science to learn about that stuff, because honestly, they're not going to teach you that stuff in an academic program anyway. That's just something you kind of learn as you go. And the kind of related tools like using Git or GitHub or whatever, very, very useful. Yeah. Okay. Anything else? Let's see. Oh, so another question was, you mentioned working with advertising data. What do you do with that? So it's complicated, right? So the first thing I would say is that the online advertising ecosystem is extremely balkanized. So there are just a ton of companies, and they all kind of do their little piece in that ecosystem. And somehow, you know, the data flows through in one direction and the clicks flow through in one direction, and then the money flows back through in the other. And there might be 10 people in the middle, and they're all taking their cut of things. So it's pretty fascinating, and what you do with the data really depends on where you are in that process. If you're on the publisher side of things, you need to be tracking the eyeballs that are coming to your sites and making sure that they're converting on those ads that you're showing. If you're on the other side of things, when you're buying those ads, you need to make sure that you're not paying too much for them, and you need to make sure that you're getting good quality traffic for what you're paying for. So it's a similar kind of thing, but kind of on the other side. And then, you know, as if you have players in the middle, so big ad networks, so Google or Bing or I think Amazon is also a large ad network now. So they kind of sit in the middle of all this interaction. Yeah. And so, I mean, like in terms of what do I actually do with it, you know, you might be interested in the click-through rate, for example. So you can fit a model to that, and then you can start predicting what types of people are going to click through what types of ads. And that's kind of related to like recommender systems, but you want to have a well-calibrated probability for it, not just like a hard recommendation, because this is going to plug into other things that you might want to do. So for example, if you have like different strategies for what kind of bids to place, you want to have a good CTR estimate so that you can calculate your revenue per click, for example. So you might take that CTR you've estimated, multiply that by the expected revenue, and then you have a revenue per session, and you go from there, and you know, argmax that thing instead of just you know, showing people the top 3 biggest things. You want to shoot for dollar optimality in that kind of case, definitely. Let's see. Another question was, I work in the educational space where data science is just getting started. Do you recommend to work in commercial ventures to increase the opportunities to learn more ML models, algorithms, tools, etc.? I mean, not necessarily. So the industry has industry problems, and they will use industry tools to solve them. And that's fine, versus, you know, in academia, that's going to be another set of problems, you know, like generating novel research and publishing. And then in the educational space, it's going to be yet another set of problems they're trying to solve, and generally different kinds of tools. When I was a stats consultant at UCLA, I definitely saw this kind of play out where the different departments would literally use different stats packages. So the econ people would use Stata, the education people would use SPSS, the psychology people would use some SPSS, some more specific stuff that was floating around UCLA. In statistics, we used R quite a bit. In other parts of campus, used Python. And I mean that's just at UCLA, right? And so if you imagine exploding that out to like all of industry or all of education, for example, it's going to be even more like that. One thing that I would say is that if you are joining a new team or working with a new client, it is important to kind of meet them where they are. And it's better to join a team and learn how to use Python at a Python shop than it is to try and get all them converted to R or something like that. The whole point of writing code, I mean, the fact that the computer can run it is, that's good. That solves the immediate problem, but it's going to be other people that have to actually read it so that they can fix it when there's bugs. Yeah. Let's see. Another question is how to get an interview opportunity as a new graduate in data science. Thanks. No, that's a good question too. And I think one of the most, well, I mean, there's a couple different things that have worked for me, but they all kind of boil down to, trying to leverage the strength of many weak connections, right? So like I said, if you're on a lot of email lists, you might see the right thing that comes through one day. Or if you talk to a lot of people, you never know. But I mean, everyone kind of has their own path. If you're a new graduate and you really want to go work for Google, like, I don't know if I could help you with that, but what I could say is that, if you're going into industry, there is a great big ecosystem in most industries. So if you were going into advertising, there's hundreds of these different companies that need data scientists desperately, and they might be a little hard to find. They might be a little off the grid, but they are around. And if you go to different meetups, for example, you might bump into people. If you go to conferences like the Ideas Conference coming up, you'll definitely meet some people. And maybe not the exact right people, but they might know some people, right? Or they might have their own private Slack, and then you're on there, and then you meet people kind of in a second degree fashion. So I mean, that's one thing I would recommend. Couple other things that I would recommend that have worked out well for me is to have a good portfolio. That could be on GitHub, which is what I use. Every once in a while you'll get an email and people say, hey, thanks for putting that on GitHub. That was really helpful. And then probably 3 times rarer than that, you'll get an email that's like, we're using this at my company. Can you help us out or whatever? So I'd recommend that. Another thing I would recommend, and this can't just be me, but it does happen once in a while, is I'm on Stack Overflow. I try and answer questions there. Sometimes you will meet people in that particular chat, and those people tend to be pretty good connections too. So those would be my kind of two kind of weirder recommendations would be GitHub and Stack Overflow, I guess. And that'll be more geared towards people on the more technology side of things. Probably wouldn't help if you wanted to, I don't know, go be a data scientist for a hospital, for example. That's a totally different job, and I couldn't speak to that as much. But I'm sure they have similar kinds of spaces online that thing could kind of happen to. Let's see. Let's see. The other question would be, do you think when you are ready for your hunting a job as a data scientist? Thanks. So I mean, I'm going to interpret this question a little bit of like, how do you know when you kind of know enough to consider yourself as a data scientist? And I would say anyone that can, you know, look at numbers should think of themselves as like a data scientist in some respect. The fact of the matter is a lot of businesses, they just run in Excel, and you know, in the land of the blind, the one-eyed man is king. And so that's where a lot of people start, right? Is, you know, maybe you're, you know, with a moving company and they have like a whole spreadsheet full of like which moves they need to move and where to send the trucks around. You can do some data science there, and it doesn't have to be fancy. It just needs to be better than what the state of the world is right now. And so a lot of cases, it's just like, just look at the data and make some plots. You'll probably learn something from it. And you're a data scientist if you do that and no one else in your company is, right? So that's where I would say, like, you don't need to go learn a bunch of stuff to be a data scientist. Like, there's a new gradient boosting package every year. It's not like the old one. It's not like you, unless that's like specifically your job, you don't need to know every single one. Like, you don't need to know 4 different deep learning frameworks because they have slightly different feature sets. You know, and like I say, if you want to go work at Google and that's what you do, that's one thing. But my experience working at kind of the smaller to medium sized companies is it's about making a contribution at your company. And just going a little bit further on that quantitative spectrum than where other people have, and kind of pushing the limits that way. It's not about, you know, knowing a bunch of frameworks or anything like that. Let's see. Another question is, do you have any suggestions for new grads with non-CS engineering majors who have some sort of data analysis experience? Definitely. So, and I think you're going to have to probably spin it a little bit, but I think a lot of times that's when you're in an actual science, as compared to like math or statistics or CS, you're actually working on the application, right? So if you're in, for example, environmental studies, you might be studying, you know, the rainfall in different areas. You're actually working on the problem and you're using the data to figure it out. And a lot of times I would not, you know, I would generally rather work with someone that with like some domain expertise than someone that's just gonna, like, even if they're just amazing at Kaggle or whatever, if they're just gonna dump the data through a black box without thinking about it, it's probably not going to work out as well as someone that actually cares about the data and tries to understand the underlying processes. And I think a lot of the sciences do a pretty good job at that kind of thing. Like, so if you're in chemistry, you understand how the molecules work, right? It's not just about, you know, inputs and outputs. Or similarly with genetics, like there's a lot of machine learning that they're using in there, but it's for a reason, and you understand kind of the pathways that make, for example, hereditary diseases happen. Let's see. Let's see. Another question is, you were talking about posting your work on GitHub, but what if we did those projects for someone and are not allowed to share the actual code because of confidentiality issues? Or if the codes we wrote were for a particular project and they are not actually very useful without the actual data, and you can't share the data. So that's a good question, and I think one of the things that I try and think about is, you know, if I solve a problem, then what does that software also solve? So an example of that is I wrote some software for detecting change points, right? And so that was originally for looking at, you know, click-through rates. So is there a change point in the click-through rates? That's fine. But it is a more general problem too. So you can imagine using that with, for example, looking at server failures, for example, or you can use it to look at, you know, are there hard changes in people's voting patterns based on the different candidates that are running, or demographics changes. So you can usually kind of try and generalize that way. And if you go with that, you can usually find some data out there, or you can scrape it yourself for those kinds of purposes. So the change point data, another thing I used was like, were there any change points in people's opinions about The Simpsons? You know, for how many episodes did it go before people kind of stopped caring? Let's see, another question is, how to deal with the issue of experience requirements such as 5 years. I'm a new graduate and have limited work experience. Thanks. So, I mean, one thing I would recommend is that when you're a student, you're still generally working, or at least I was. So I was TAing, I was doing stats consulting, that kind of thing, and that's like a fair amount of experience that you already have, even though you just got your diploma in May or whatever. So you can think of things that way. And I count it on your resume that way too. The other thing I would point out is that a lot of job ads are not written realistically. So if someone asks for 10 years of experience with TensorFlow, that was pretty clearly written by someone that didn't know what they were talking about, because it didn't even exist back then, right? So that's not something I would tend to worry about too much. I know that there is a lot of competition in the industry, but almost never do people apply like hard filters where it's like, oh, everyone that's over 30 makes the cut and everyone under 30 is out. Like that's not how it works. It tends to be more like, all right, the people that have worked at a job and were successful at it, or had equivalent experience somewhere else, you would go with that. And that equivalent experience, that could be some extra education, it could be some side projects, could be a lot of different things, I guess. It could be if you're, you know, volunteer for DataKind or something like that and work on a project that way. Yeah. But in terms of like the stuff where it's like 5 years, 10 years, like I tend to just assume that those job ads weren't really, they were written by like HR departments or something, and not the actual hiring managers. Let's see. And another question is there an age issue to hunt a job as a data scientist? Thanks. I don't think so. I know the federal regulation is that you can't discriminate against older people, but you can discriminate against younger people or something like that. So I mean, I guess it's possible. But I mean, the idea of like the job of a data scientist is still pretty young. It didn't exist when I was in college, and now it seems to be a thing. 5 years ago, most companies only had one data scientist, and now we're starting to see teams of data scientists and people being a bit more specialized. And there's certain specialties, I think, that rely more on experience, and then there's certain specialties that are more about like, let's say like knowing specific technologies, and then there's certain specialties that are more around like figuring out what the data is doing and troubleshooting it that way. And they all have different requirements. It's almost silly to use the same job title for them. And I think over the next couple of years we'll start to see that kind of separate out. But yeah, right now the job title of data scientist, that could be it could be one of like 5 or 10 different specialties, or a mix of several, and it could be kind of anywhere in kind of a seniority ladder. Like it's just vague. You have to go through a lot of job ads and kind of read between the lines to figure out what a company might be looking for and if you're a good match for it. But you know what? It's free to apply for a job. It doesn't take a long time to send off a resume. So you might as well. The worst case is that they ghost you, and you can't take that personally. And then the best case, like maybe you make a connection or you get a job. You just never know. But it is about playing the odds, I think. Okay. Just an announcement from Austin. We've got about 5 minutes left. If you have any further questions, make sure to ask now. I'll also take a moment just to, again, mention a couple of weeks from now, there's the Ideas Conference. It's, let me check the date real quick. It's Saturday the 20th in 2 weeks. I'll be there. Hopefully you all will be there. It'd be great to meet you all. Yep. Let's see. Another question from Bintao. Although AI is hot, why is it hard to find a job by such a skill set? Thanks. So I think especially with AI, there's a lot of companies that don't quite know what to do with it. Versus if you said, all right, I can solve logistics problems and I'm doing that using AI, that would be something that they could understand. Versus they're not going to say, oh, we need an AI person. They're going to be thinking we need someone that can like make our trucks go in the correct routes or something like that. Most businesses are coming from like, we have a problem and we need to solve it, not from we have a tool set and find interesting things to use them on, you know. Okay, one last question. Do you have any links or resources to help you learn AI for free? Thanks. Um, so I'm mostly coming from a statistics background. One resource that I've definitely benefited from would be the Elements of Statistical Learning by Hasty and Tibshirani. That's free on their website. It's a great book. I revisit it every couple years, and I've learned a lot from it. The other resources I would really recommend are the open source community in general. So if you get on like the NumFocus mailing list, they have projects coming out all the time that are helpful. And, you know, getting involved in one of those projects can be a really good way of getting experience and learning how those different different tools really work under the hood.
Okay, cool. So that looks like all the questions we have time for today. So yeah, so there's like a few more things to mention. Again, we have our conference coming up in 2 weeks at the Los Angeles Convention Center. And I'll put the link again for our website. We also have a profile on Neal and the rest of our speakers that'll be at that conference there. So be sure to check that out. And then one other clarification is that Neal mentioned DataKind, and I just wanted to put a link out there for that. It's just a place where you can volunteer and work on data and not have to apply and get a job in order to get some experience. Another place that would be great for that, both for learning things and for getting experience, is Kaggle, which has machine learning and things like that for competitions and ways to learn how to use the things. They have a bunch of different notebooks that show how to do the projects and things like that. So that's a great way to learn because it gives you the data sets, and it also gives you a bunch of examples given by people entering the competitions. So that's a great way to learn, by seeing how other people performed well in these competitions. So yeah, I'm going to put those links in the chat here. And then other than that, that'll be the end of our webinar. So thanks for attending, and we'll see you next week for another speaker.
Yeah, thanks.
Thanks, Neal.